Hello, hello. Yes, so yeah, I'm Andrey, and I'm going to talk today about very weird stuff, indeed. Probably none of you have heard what is Yamlware, but probably you know by heart that what it is, because a lot of people are using YAML nowadays. How many people actually have never written a line in YAML? Never ever. One guy? Two guys? Oh, I know you did. Okay, so only one guy is not aware of maybe of all the problems that you will probably face when you start doing something with YAML. But obviously YAML became a very popular way to define a lot of things, like crazy amount of things. But okay, so who am I? My name is Andrey. I am a developer. I have a developer mindset. I will keep coding till I die. That's no doubt about that. But also, I'm the one who is consulting a lot on DevOps topics and automation topics, and that's why I'm kind of get in touch with all these tools like Ansible, Terraform, Kubernetes, and all that stuff. And I have my opinion on them. So this talk is about my opinion on those tools and my opinion about like YAML and the different data structures. Okay, so just to make a definition, Yamlware is anything that is kind of using configuration infrastructure deployment as code. And it's not just YAML, it's not just that format, it's actually could be anything else, because there are many more different languages that exist that you can use to define same things you can actually define in YAML, so I don't distinguish them that much. So this is the term I came up with, nothing fancy, just for fun. So this talk consists of two parts, and both parts is basically just whining about the tools and about the formats. The first part, I will whine about, I will cry about YAML, and the second one, I will cry about the structure and the state of the tools that are using YAML to define the infrastructure state and stuff, things like that. Okay, so part one, YAML. How many people think that YAML actually is a good format? Okay, how many people think that it's actually bad, very awful one? Roughly the same. And I think both of you are right, because it's both bad and good. And initially it started as a very simple format. I think it was around 2005, if I'm not mistaken, when the first YAML spec came up. And the idea was really simple. I mean, we needed some format, and everybody hated XML, and nobody wanted to use anything like HTML and any other complex formats. So people wanted something that is used for data serialization, for data exchange. And at the same time, this has to be good also for human to read that stuff. So YAML was designed with two goals in mind, and it was human-friendly, human-readable, and it is just a plain data serialization format, which is a nice goal. These two goals, I guess, made it very popular, and pretty much any tool on the planet at the moment, well, not any, but quite many, are using YAML as a way to exchange configuration, data, state, and stuff like that. There's even things like that appeared. Senior YAML engineer. It's not a joke. It's a real job advertisement. Companies searching for a senior YAML engineer because, well, of course, it started as a joke. Of course, many people initially thought it's a joke, but obviously, when someone says, I need a senior YAML engineer, most of people who are inside automation and inside DevOps kind of topics, they know what is being meant. We want a configuration manager. We want a person who is capable of tolerating the tons of YAML that has to deal with daily. So this is a real job, and I think it's still open. If you want to get on, you can find it out. And probably it's not the last one. Probably some other companies will start, advertising and hiring senior YAML engineers or lead YAML engineers, or YAML team leads, or something like that. So YAML is extremely popular. It's extremely widespread. We know that. But at the same time, YAML is awful. I mean, it has a lot of drawbacks that are the initial design decisions that were made for YAML. They actually striking back and making a lot of things a bit harder than they should be. So many developers actually, well, many people came up with jokes about YAML, creating this kind of warning signs, telling you that YAML warning, there's a lot of YAML here, or maybe tweeting about that YAML is a great language and showing all the possible errors you get in GitLab CI, for example, in this case. And the funny thing, actually, there is a special hashtag for that. It's called NoYAML. Just search for that. You'll find a lot of funny things. Twitter, Facebook, Instagram, it's there. It's a reality. Also, and it's there not for a bad thing. It's actually there because there are some bad things in YAML. Did you know that you can actually do things like that in YAML? So this is YAML injection. We inject code into a YAML parser, and it will actually execute that. In Python, of course. If you're using Python-based tools, it will actually do that unless, well, most of them actually fixed that by now. They don't allow that anymore, but it was possible a few years ago. So YAML injection, that's a reality. Of course, it's not something you want to do in real life, especially with your Kubernetes setup, I guess. Another thing that kind of puzzles me and strikes me, actually struck me several times, is that officially neither JSON nor YAML supports duplicate keys in the dictionary, in the format, but they are actually possible. And I've met several tools like Docker Compose, like Helm, and several others that didn't ignore duplicate keys and didn't warn me about duplicate keys. And I was, shaking my head and trying to understand what is going on in a huge YAML, when eventually realizing that I actually have a duplicate key somewhere. And just to be precise about that, YAML says that there should not be, and there actually must not be any duplicate keys, but the tools that use YAML to parse information, pass information, actually allow that. And that's a problem because specification doesn't dictate the tools how they're being used. Okay, indentation is a problem, is a huge problem of YAML, and many newcomers and also seasoned developers also face that issue because YAML basically is representing a data structure or a data model that is actually something else, but the format is very simple, and if you don't know what is data model, you can make easily mistakes not knowing which name is actually where and what kind of things we're trying to name. So actually, this is real code in Ansible. It will work, but it's kind of cryptic. You don't understand which name is where. Well, this is my favorite. Did you know that in YAML you can encode integers with base 60? How many actually knew that? No. So basically, if you use colon, you can kind of encode time or angles, and this will just multiply that by 60 and 3,600, eventually resulting in an integer. So I guess you see where this could be a problem. If you do a port mapping for Docker, or for Docker Compose or for Kubernetes, and that port is actually below 60, you will get surprises. So for example, 25:25 will give you an actual integer, which looks like that, and well, this is SMTP port, this is a DNS port. You'll be quite surprised what you get in there. And of course, in order to overcome that, you have to use quotes around the string, otherwise you get an integer that doesn't look in the way you want it to look. And actually, in Docker Compose, in Helm, they actually specify that this is a feature of YAML that you have to know about, especially when you do port mappings. Okay. Another thing. Did you know we can do something like that in YAML? Can you understand what is going on here? I mean, it's a list of two things, but one thing is starting with and, another one is starting with this one, I mean, can you actually comprehend what is going on here? Anyone? Did anyone use this kind of techniques before in YAML? YAML templates? Well, one guy. The thing is that, I mean, what happens here is that this is a template, and this is the way we call that template. So this is a reference to a template. Seriously, I'm a developer who knows several programming languages. This thing hurts. It insults me. I don't want to even look at that. It's hard to understand. Most people don't know that YAML can do that, and some people do. And then when you end up with code like that, which is extremely unreadable. And if you remember, initial goal for YAML to be created is to actually be readable for humans. This is not human readable. Another one, Boolean. 22 different values can define a Boolean. They all are valid. Of course, one joke that is usually made in this regard, so if you want to represent Norway country code, you actually will get a Boolean instead. You'll get true, or actually you'll get false. And of course, if you want to represent the actual value, you have to use quotes. And that's kind of rule of thumb in YAML. You have to use quotes if you really mean that string. Otherwise, you may get surprises like that. And of course, it doesn't support anything like other languages. Okay, another thing that is problematic for formats like YAML is that, well, probably you guessed that, you can actually truncate YAML at any point in the file, and it will still be a valid file. You can copy-paste it accidentally from Stack Overflow or from Slack, and then paste it into your editor. And if you forget, like, last part of the file is still valid. That's a kind of, a feature of YAML and a limitation at the same time. It's if let's say if you're sending YAML over the network and network broke at some point, the other side will not know because they will still get a valid YAML. There's no way to validate that, at least on the YAML level, on a data structure point of view. This is my favorite one. YAML is not Turing complete. How many of you actually know what is Turing complete? Some of you. Well, I have to admit I'm also not fully understanding what Turing complete means, but it's a very smart argument you can make. For any YAML lover saying that, oh yeah, but it's not Turing complete. Yeah, go away. But the problem is that, of course, it's not Turing complete. It's unfair to compare it to that because Turing complete means that we have a language that describes computations. YAML is a data language, so you cannot say that data language is Turing complete because it will never be. It's a different purpose, a different paradigm, different universe. So basically, YAML is a data structure. And of course, theoretically, you can describe any program as a tree structure and put it into YAML, but this doesn't make YAML a computational language. It's not a computational language. Okay, so do you think, after all of this, do you think maybe JSON is better? No. Well, no command. Well, JSON doesn't have commands. That's the problem. In YAML, at least you can comment your code. Okay, XML. Anyone? So yeah, but honestly, I think I should stop whining. I should stop complaining about YAML. And I mean, it's just a tool. It's just a simple tool that served its purpose. Unfortunately, because of its popularity, it's being overused and abused a lot. But overall, it's just a data structure that it's. I mean, how can data structure be bad? But still, there is a need. There's a need in the industry to actually have some sort of standard, or at least several ways to define declarative intent, describe configuration, manage state or share that state, serialize data between different machines, computers, or people. We still need some sort of language. And when industry needs something, it goes and creates that. Well, of course, we have YAML, we have JSON, we have XML, but, well, people didn't stop there. There is JSON.NET, which is kind of, it adds on top of JSON, it adds additional functionality to give you functions, to give you arithmetic, to give you conditionals, to give you variables. And it's still quite declarative, it's still quite, it's not a computational language, it's still a data language, but it's more comprehensive. So any designers here, by the way, whoever created CSS style sheets? CSS has the same problem. Oh, there's one girl. CSS has the same problem. It's very dumb language. It's nice because you can control the browser and make it cool. But if you want to use variables, if you want to use functions and templates, you have to use something else. And for that purpose, industry or community has created SAS. And similar things have been done for JSON and YAML. So one of them is JSON.NET. Another one is JSON 5, which is the next incarnation of JSON, which is, well, I mean, I don't know why they think that JSON is for humans. I'm not sure, but they claim that JSON 5 is for humans. Let's hope for that. Another format that is not totally interchangeable with YAML or JSON is TOML. It's also a hierarchical data structure, but it looks a bit like Windows ini file if you're old enough to know what it is. And it's a bit extended, of course, and it also allows you to have some nested structure, some lists, some dictionaries and maps, and it's actually quite simple. And in my opinion, it's slightly better than YAML for certain use cases. But yeah, okay. Another one that, or maybe it's too small. This one actually, I haven't used it yet, but at the moment I look at that, it looks very nice, very promising. It's also a language that adds additional variables, functions, types, modules on top of YAML or JSON. So if you have a complex configuration that you want to generate and get YAML output or JSON output, you can actually use that as a preprocessor or as a compiler for your YAML files. Well, why not? And that's one of the use cases for that actually is to generate Kubernetes YAML files. Another one, which is also very similar, slightly different syntax than DHL, but the idea is pretty much the same. Also adding functions, variables, and all that stuff on top of structured templates, structured data, and allowing you to use loops, variables, ifs, and all to generate the final output that will eventually be fed to the final tool. Also, not quite YAML, and a bit more advanced is HCL, HashiCorp Configuration Language. I think it will be mentioned several times, and I think it was already mentioned by Anton in his talk in different room. Probably you will encounter that as well, but it's a language used by Terraform, but not only Terraform. And you can actually use that as well to generate YAML output if you want, or JSON output if you want. It's more advanced, and it has very nice, in my opinion, this has very nice syntax. I like it the most. Okay, so you probably have seen this comic, right? We have 14 standards. Let's create a new one that will fill all the use cases, and now we have 15 standards. That's a classic joke. And of course, I think it's still important to understand what was the original design decision for YAML and for other languages, and whether we can use higher level languages to generate the low level data serialization format that we need for our tool. That could be a way out from the situation with YAML. If you really want to use like a real programming language, one way to do that is to use another tool that's called Pulumi, which is kind of similar to tools like Kubernetes and Terraform in a way, and allows you to actually use a real language. If you are a developer like me, you probably will feel better in this universe, but that's another story. Okay. So just to define again, that YAML is good for defining serialized data and declared state, but it doesn't have support for different constructs like variables, functions, and depreferences, and also it's not very good format for. It has some gotchas, like I showed you within the specification, and it's also not very good to implement some sort of imperative or sequential scripts with that. And unfortunately, some people try to do that. For example, Ansible does that to some extent. Okay, so part number 2. So I hope we set the ground with how to feel about YAML. It's just a language. But let's talk about tools now, which are using YAML to define the state. And we're using different, actually not just YAML, but actually some other languages to do that. So let's talk about the machine. Okay, so some nice photo. I'm talking, and yeah. So many tools that we use to provision infrastructure and to provision actually anything, not just infrastructure. It could be I don't know, anything. I'm working with infrastructure. That's why the only thing I can think of is infrastructure. But of course, it can be used for anything. And the idea of using a format that is declarative and readable by humans is that, and in many cases it is YAML. In some cases it's not, but in many cases it is YAML. Is that we can take that data structure, which usually is a graph of dependencies between different resources. We can parse it, and we can also maybe query stuff from the world we're trying to manage. And eventually, based on the information from the world, based on the information from the code, we map it all together and determine what kind of types of actions and the number of actions we have to actually execute against the world to become equal to our code. So many tools work like that. It's not just one or two. It's actually many provisioning tools, many infrastructure as code tools work in that way. We have a declaration, which is human readable, and we have an engine that figures out how to do the stuff. So basically, YAML is just the declaration of what, and heavy lifting of how is done by the machinery implemented inside the tool. All the logic, all the complex logic is done there. So, okay. Let me show you one example, one made-up example called Yamlware. Imagine we have a super fancy engine that it knows how to manage planets and universe. It's called Universe State Engine. Use. It doesn't exist, but you know they just released version 1.16 this month. It's a good one. So. And yes, it has a command line version, and you can run it and get stuff out of that. And it works in a way that you provided a YAML file with declaring what we want to do with our system, and in our case, it's going to be solar system, and apply that to our world, which in our case will be solar system, universe. Also, there are a couple of companions that work in that universe. One is called Fume, which is basically a monitoring engine. And another one is called Jobs, which is basically a CI engine. Okay, so let's assume, let's play with that. Let's assume we can feed some YAML into that. So, you know Pluto, right? Pluto is a planet, or exactly. So we know at some point it was a planet. So we have this nice YAML was defining our planet, and at some point we decided no, it's not a planet anymore. But actually, it doesn't change the state of Pluto. It just changed the metadata of that. So we just we change the type, and we go and run our solar system YAML against our universe, and you see modifying Pluto. Pluto's metadata is fine, modified, all fine. It's all like 10 nanoseconds. And then we had some report from our monitoring system that, okay, libraries on Earth have been updated, that everything is now in place. Everybody is aware now that Pluto is actually a dwarf planet. Nothing, well, well, it's working. The engine is working, nothing has changed. Okay, let's play with that. Let's define a comet, a new comet in our universe, in our solar system. How would that look like? And because we're using declarative language, because we in this case we're using YAML, we just say, let's create a comet. Let's just define it in our solar system.yaml, and then let's say it's going to be one comet, and well, because naming is hard, I just name it my comet, and yeah, just set the speed, and we just go apply. Use apply and blah blah blah, and our engine is actually capable of applying that information into the solar system and make it work. So comet is created, but we get some weird stuff from Fume. A known object is approaching Earth. Okay, what's that? Well, this looks like a serious thing we have to work on. So, of course, all DevOps engineers are called on, and they look at the warning and try to fix that. And they, of course, look at the code, and they see that some young developer has committed a new commit to the production branch. That is bad. Well, the thing they do, they just remove commit code from the YAML file, and they try to apply it again. Well, use looks at the code, says, well, it corresponds to my understanding of the world, so no changes applied. And Fume is still complaining. And actually, this is the problem that is common for many configuration management tools. If you remove the code from your declarative nice definition, it doesn't remove the resource. Kubernetes works like that, Ansible works like that, Puppet works like that, Chef works like that, Docker Compose works like that. If you remove the code, the actual object that has been created before stays there. So you have to compensate. You have to go and do some compensating actions and actually delete the comment. Then the danger is over and Earth is saved. But that's something that many configuration tools are actually have a problem. The one tool that doesn't have the problem, at least one that I know, is Terraform, which actually preserves the information about what was the previous state. Actually, another one is Helm, but it's a different story. Okay, so let's do something with Earth production system. Yeah, let's add a moon. I mean, we have one moon for centuries. Let's add another one. It's just boring to have one moon on Earth. And of course, we'll just add another moon. And because naming is hard, it's just moon 2. And we do the same thing. It took a couple of years for the engine to finish the application, and Moon 2 is up and running. We're happy. Now the citizens of Earth can observe the double moon on the horizon. The problem is, yeah, we're still getting some warnings from Fume. So obviously, at this point, in this particular case, in this particular code, because moons were kind of attached to the planet object, and the kind of planet is controlling them, we just remove the line. And in this case, when we remove the code from our nice solar system.yaml, it actually removed the moon as well. So as a miracle, everything was solved. Okay, so of course, our solar system project is kind of going on, and we starting using issue tracking system to report bugs. And there's an old bug that exists in that system called Earth is overpopulated. Of course, I mean, we have the best state engine in the universe, which can control things, which can fix things for us. We just have to declare our intent, and that's what we do. Why not? I mean, we just say that let's increase the radius of Earth. I guess everybody knows that it's in real Earth it's like 6,500 kilometers. Let's put 8. I mean, why not? I mean, it should be bigger. I mean, it should be enough there should be enough space for all the people to actually live on that. After that, okay, and we started to use Git at that point. We use fully GitOps. So we changed the code. We edited the file. We committed. We said that we actually fixed the bug. Yeah, we're happy. We have the history of changes now. It's cool. And of course, our CI system started to do something about that. So starting a Java commit, running script, using apply solar. What? Destroying Earth? Why? Yeah, it's not a bad thing, of course. It's not a good thing, sorry. And the reason is, of course, because we didn't know of all the side effects that our engine has. Because some attributes inside the object definition are changeable online at runtime and without any side effects. Some attributes will actually require recreation of the resource. This is one of them. And this is another problem that some of the tools, especially Terraform in this case, have. That if you modify some of the parameters of the resource definition, just changing the size or changing the base image or changing the location of the server, moving a different subnet, for example, will actually destroy the server or will actually destroy the database. I made this mistake many times. I actually was destroying several clusters with that. Luckily, not Earth. So yeah, it's another problem that this kind of state engines actually have. Okay, and because of this incident, we had like a upper management meeting, and we decided that we actually have to do backups of our planets from time to time. So because our declarative system allows us to actually do that, yeah, we created just a backup job for planet backup Earth, and we just run it every minute, just in case, if shit happens. And in 10 days, we get something like that. So no space left in space, which is kind of, ridiculous thing. Okay, enough joking about that. Yeah, and basically, real-life state machines work in a similar way. So Kubernetes works in a similar way. Terraform, CloudFormation, serverless framework works like that. Ansible, Puppet, to some extent, work in the same way. And many others work similarly. So we declare the code. We have the engine that has to figure out how to actually apply the state we declare in the code. And then, well, hopefully it works. But in many cases, it doesn't. We have to be aware of what is going on, of course. Okay, important thing about these tools. How much time do I have? It's on 1 minute. I have so much content, actually. I hope you're still with me. So yes, important thing about these tools is that they all are idempotent. Idempotent means, I hope you know that, it's basically, well, it's a mathematical definition, but also it's quite often applied to computer science, is that if we apply an operation multiple times to the same state or different states, we still get the state described in the original code or original function. So, for example, this script is idempotent because apt-get is installing a package, and if the package is installed, it will just say, OK, it's already installed, and will not complain. If I do something like that, if I try to do user add Andrey, and let's say user Andrey has already existed, then this script actually is not idempotent, because this command is not idempotent. It will fail the second time. It will succeed the first time, it will fail the second time. So in order to make this code idempotent, of course, we have to add some additional code. As you can imagine, in this specific case, it's easy. It's easy to understand, it's easy to comprehend. But if you have to manage all different attributes of user, or all different attributes of package, or all different attributes of cluster, or whatever, this code, this imperative code, grows very big and very, very incomprehensible, hard to understand. So that's why people created this kind of tools for actually managing things in a declarative way, and then the engine figure out what to do. So the previous script will probably implement it in, let's say, Yaml or in Ansible or some other tool in a way like that. We just declare what we want, and it's much more readable than the bash script, of course. So we strive for readability, we strive for declaratives. That's what we need. OK, and of course, because it's idempotent and because it's declarative, it's very CI friendly and very pipeline integrated, because we can just run it inside the pipeline and it will always run. And if everything is OK, it will be green. If something is broken, it will actually try to fix it first. And if it doesn't fix it, then we get a red pipeline. Yeah, also we get a bit of better abstraction level. So we work on different higher level abstraction on that. We also kind of not working with plain text files or plain commands. We're actually starting to work with resource graphs. And if you look at what Kubernetes does, what Terraform does, what Puppet does, for example, it's actually working with resource graph and figure out what are the dependencies between different components of what we're going to execute. And it can actually make some magic around that. One of them is actually parallel execution. So as you can imagine, if you have a defined state with many, many different objects, if some of these objects are independent of other objects, you don't have to wait for those objects to be executed. You actually can do that in parallel. So for example, Ansible is not capable of that. It doesn't know the dependencies between the different tasks. Terraform does know, and Puppet, for example, does know that, and they can actually run several things in parallel because of that. Because they build the full graph, they find the clusters which are independent, and they can run things in parallel. This, of course, going to be much faster than if you have a sequential script which you have to run anyway. Yeah, also this is has a side effect of having right ordering on stuff. Also, these tools provide some of them provide some better modularity to actually package their abstractions and even higher level abstractions, which is a very nice thing. Another thing that these tools, most of them, the state machines actually have, is that they actually have an ability to query the world that they're trying to manage. And that's actually quite powerful, because you can base your state, your definition, not just on things you want to have, but also things that may exist in the world already, and you can inject the values of those objects into your code, into your declarative definition. And that's one of the things that is quite important. And resource deletion is one of the things that is not supported, as I already mentioned in the Earth example. Another thing that you have to be very careful when you manage different attributes of a resource. Some of them are write once, so you can only write them at the beginning of the first creation, and then they're not changeable after that. Some of them are updatable and applied online automatically. Some of them are require some extra action to take effect. So one example from real life is persistent volumes in Kubernetes, if you ever worked with them. And some of them actually forces resource recreation. So as I mentioned already, I personally myself, I destroyed Kubernetes clusters in production because I just decided to change the base image for the default pool in Terraform. And when we are defining the state, or using YAML or different other or any other language, in fact, we have to understand what we are defining. Which attributes are write once, which attributes are actually dynamically updatable, which attributes require some extra things and extra compensating actions. We have to be aware of that, because otherwise it seems like magic, and disasters may happen. Yeah, resource recreation. Also, some tools provide you resource protection, so you can actually protect resources from being recreated if there's a need. And this is like a very good thing if you can integrate into a pipeline as well. So test it before. Many of these tools, many of these state machines also provide you a way to actually make a dry run, something that we should have done with our Earth before, increasing the radius. To test what would happen if we increase the radius. Most of tools like Puppet, Chef, Ansible, Kubernetes, Helm, they do support dry run mode, Terraform as well, where you can actually see what kind of actions are going to be done when we run this code against the current state, and that's quite important. Yeah, this is something we have to do sometimes as well. Also, some of these tools, some of these machines actually differ in a way they verify the state that we're trying to apply. For example, Terraform it does verification at deployment time. So it deploys when we run Terraform apply, we actually verify that all the things are exactly as in code at the moment of deployment. On the other hand, Kubernetes has a different way of doing things. When we do kubectl apply, we send code to the API server, and then it determines what actions should be applied, and it does that, and it's at its own convenience. And if something is broken during runtime in that state known to the server, it will actually compensate automatically and will try to fix that at least. So different level of tools. Most of tools are deployment time verification. Some tools like Kubernetes, for example, is runtime. Okay, we have this one, I have no time at all, but let me show you something. I promised few slides, only a few slides. So I came up with this idea that we actually have to measure the tools and measure the quality of the state machine that is implemented in any of the provisioning tools that we currently using in a way that how mature they are on different levels. So whether the tools are important, what is the chance of actually breaking the run in the first run, how declarative, how readable it is, how rich is the query about the world we can do and integrate that with other code that we have. What is the execution engine maturity? Can we make a parallel execution? Can we do auto ordering? Can we delete obsolete objects? Also, can we make higher level abstractions with modules? And how mature is documentation? And based on my experience, based on my opinion, I created this simple matrix for these three tools: Kubernetes, Terraform, and Ansible. And I put it like that. So in my opinion, Terraform is stronger as a state engine, as a state machine in some cases. Kubernetes is stronger in other cases, but Ansible is worse in everything. That's my opinion. We can argue about that if you want, but that's the idea. Yes, I have these simple descriptions of what everything it does, and Ansible is pretty dumb. It's just connecting to the servers and running SSH command again that based on the code described here, and it doesn't support resource dependencies, it doesn't support parallel execution, doesn't support a lot of validation. And what I've seen is that quite often Ansible playbooks are turning into really hard readable things, especially if you implement something complex, the readability suffers quite fast. If you're doing something simple, it's okay. Well, hello world things work for any tool, by the way. Okay. In Kubernetes, it happens kind of asynchronously. So we have the code, we send the code to the server with kubectl apply. And usually if the code is valid and if Kubernetes recognizes all the objects defined in that piece of code, in that YAML, it just stores that in the database. And then the magic happens between master and nodes when it tries to figure out how do we achieve that state. But the problem is that it doesn't say to the executor whether the code is failed or whether deployment has failed or things have not been created, because the idea of Kubernetes that is trying to achieve the state, but it's not, and it's doing that asynchronously, and it's not reporting back to the tool that deployed the code. There's no correlation there. So yeah, some facts about that, and some of the attributes that you have inside, Kubernetes description, they're not changeable. And that came as a surprise to me, for example, that if you want to change, let's say, the the size of the persistent volume. First of all, you have to be on a very recent version of Kubernetes, and second, you still cannot change it unless you actually delete the actual deployment that used that persistent volume. So it's kind of, you have to know what kind of object you're managing, and still the code is usually, it's not always enough to describe all the possible changes that you want to make, but most of them. Yes, I will not talk about Helm. Terraform is kind of, I think, in my opinion, it's the best implementation of state machine that you can find at the moment, and the most important thing that it actually supports resource deletion, because it actually saves information about what was the previous state when we ran the code last, and what is the cache state of the cloud resources, and if we delete something from the code, if we delete our moon or comet from the code, Terraform will know about that and will actually delete it from the cloud. So in this case, the code will actually be the exact description of what is going on in our world, comparing to other tools where we actually have to do some compensating actions for that. Okay, I think I'm totally out of time. You're still here with me, so it means that you're at least interested. So final words. Side effects are real, so you have to know the tool. It's no magic. There are attributes that are not changeable. There are things that will happen and will destroy things unexpectedly if you don't know what is going on. Side effects are real. You have to know the tool, and you know which resources you're actually managing. Also, there are tools for tools, like linters, IDE plugins, schema validators may help you out with understanding the tool itself. And everything is a spectrum. So YAML is just a tool. It's not bad or good. It may have some deficiencies, have some good features. It is, and I think one of the non-functional features of YAML is that it's very popular, and it has a big community around people supporting tools that are using YAML. So there is a big chance you'll find a tool that will help you to solve your specific problem on top of that. But YAML is just a format. YAML is just a data serialization format. Also, yeah, maybe it's important to keep your code sane. So if you see that YAML is not a way to solve your problem, if the tool that you're using is not a way, is getting too complex, so maybe it's time to use a programming language for that. Why not? Like something like Pulumi or something. Also, infrastructure as code doesn't mean you should use the same language all over the place. So it's not. It doesn't need to be YAML everywhere. It could be some other tools, and there are some other tools that help you out. And also, do not use YAML for implementing imperative logic. If there are any Java developers here, and I know there are, if you ever seen Ant and XML for builds, I mean, it was a disaster when you tried to implement logic inside XML files. Ansible and some other ones are going in the same way. Don't do that. It's just ugly. And keep it simple in general. Okay, thank you very much.